Here are the sponsors for the video tour.
Our diamond sponsors include Farm Credit Canada, Meekeren Farms, Brenk Farm Nursery. Gold sponsors include BASF, NM Bartlett, the Nova Scotia Crop and Livestock Insurance Commission, Paul Lanahan and RBC Dominion Securities, Scotian Gold, Truro Argamart, and V-Cross Nurseries. Our silver sponsors include Bear Crop Science, Bishop & Company, Corteva Agri-Science, Grindstone Creek Nursery, and Nova International Equipment. And our bronze sponsors include Cavendish Agri-Services, Eastern Drainage, Evans Manufacturing Company, Nova Scotia Farm Loan Board, Perennia, Provide Agro, TD Agriculture, Upper Canada Growers. And we also have a general sponsor, Adams County Nurseries.
Now we've just arrived at Nazinga Farms, and you're right, this is on the west side of the valley, but we're going to meet Keith Fuller here because he said he's got some interesting results in one of his research trials. Now my vehicle says it's 30 degrees Celsius right now, and it's supposed to feel like 38, so we picked a good day for this. You're lucky that we're not actually on a tour right now.
Good afternoon, everyone. My name is Keith Fuller. I'm a soil scientist here at Kenville Research and Development Center. And today I'm going to be talking to you about the PicPlus grower trial that we started in 2019. Firstly, what is apple replant disease? Well, it's a disease that has always been present in our old orchard soils. When old orchard land is grubbed and young nursery trees are replanted on the land, they do not grow well. The poor growth is caused by a complex of pathogens and parasites in the soil that attack the developing root systems of the young trees, causing them to grow poorly. So what is the PicPlus trial about? Well, apple replant disease was actually never an issue in the past because growers had access to Telone C17, a very effective pre-plant soil fumigant that always worked well. When Telone was deregistered in 2014, however, growers began to use PicPlus or chloripicrin as a replacement in pre-plant fumigation situations. It was then that we began to notice that young trees in replant situations were not performing as expected. These sites had a history of recent or non-recent apple production, so we decided to investigate. What did we do? First, we investigated the soil fumigant PicPlus. We wanted to know more about its use and efficacy and how it was different from Telone. We found out two things. The fumigant does not have the same penetrability in the soil as Telone. Also, it appears to control pathogenic fungi more so than plant parasitic nematodes. In the summer of 2019, with the help of Danny Davison from Scotian Gold and Chet Friesen, who was our fumigating contractor, we made contact with growers who were planning to fumigate old orchard land. The growers agreed to be part of a different kind of field experiment. When fumigating the land, each grower left a 60-foot length of one row unfumigated in a representative area of the land to be replanted. This enabled us to create a side-by-side contrast of newly planted trees on fumigated versus non-fumigated land at 18 different sites in the Annapolis Valley. So we used the sites as replicates in a field trial to evaluate the efficacy of PicPlus as a soil fumigant in replant and other situations. So how did we evaluate the efficacy of PicPlus? Well, we measured the trunk diameter of the newly planted nursery trees at each site in the spring of 2019, and then again in the fall. We calculated the increase in trunk cross-sectional area of each tree in the trial. The increase in trunk cross-sectional area over the course of the growing season is a measure of the growth rate of the young trees. We compared the increase in trunk cross-sectional area of the control and fumigated groups of trees. So how did the trees grow? We looked at the average tree response to soil fumigation with PicPlus at each site. What we found was that tree growth was significantly better at 9 of the 18 sites when the soil was fumigated. These growth responses ranged from 27.7 to 119.1%.
Here's an example of the contrast between trees growing on non-fumigated and fumigated land.
The trees on the right-hand side were fumigated with PicPlus at the label rate. On the left-hand side is the control with no fumigation. As you can see, there is about a 30 to 40% difference in vegetative growth in the first growing season. Did fumigation with PicPlus result in a significant improvement in tree growth across all sites? So when we used the sites as replicates in a statistical analysis, there was a trend for fumigation to increase tree growth, but it was only weakly significant. Anecdotally, smaller field responses when compared with Tilo in past years.
Keith went on to show me a comparison on an older site that was treated with Telone pre-plant when the product was registered. The trees filled their space noticeably better than those in the untreated row.
What else did we measure? We took samples in the spring of 2019 to see if fumigation lowered the populations of parasitic nematodes and pathogenic fungi in the soil. We also took samples at the end of the growing season to see if fumigation decreased the populations of these nematodes and fungi on the apple root systems themselves. So let's talk about nematodes. We were very lucky to have Dr. Tom Forge from Sunderland, an expert nematologist, to help us with the investigations on nematodes in this PicPlus trial. Tom tells us that lesion nematode, Pradylenchus penetrans, is the plant parasitic nematode that is most associated with broader replant disease complex, and it's been associated with apple replant disorders since 1930s. Lesion nematode is a migratory endoparasite.
They enter the roots. They just move from cell to cell, kind of burrowing along and using their enzymes and their stylets to ram holes in the cell walls. They slurp up the contents of the next cell, then they crawl into it and use it as a vantage point to puncture the next cell. They're literally creating lots of little wounds in the roots. In addition to their own feeding, they're creating opportunities then for other like opportunistic fungal pathogens to get in.
One of the symptoms of apple root systems that have nematode damage is an unnatural multiple branching trait as a result of the injury on the fine roots. The root tips die back and branch back out behind. This reduces the efficacy of the root system in terms of the uptake of nutrients and water. What did Dr. Tom Forge find in our PicPlus trial? Well, he found that lesion nematode Pradylenchus penetrans was present at all sites, ranging from 10 to 2,180 nematodes per liter of soil. A tentative threshold in replant situations might be 500 per liter of soil. Across sites, PicPlus was only partially effective at suppressing lesion nematode populations through the first growing season. This is consistent with the conventional wisdom about chlorpyrifos. Tom Forge also notes that dagger and ring nematode were also present, but less frequently and not normally associated with replant disease. In the fall, Tom Forge looked at lesion nematodes in the root systems, which is an indication of a level of infection. And again, we found that root systems from trees growing in fumigated soil had lower, but not statistically significantly lower counts of lesion nematodes. One of the really interesting things that Dr. Tom Forge found was the number of lesion nematode per gram of apple roots at the end of the growing season as a function of the site history. You can see here that in the 18 sites, approximately half of them had a history of recent apple production, and the rest had a history of other crops such as corn, soybean, wheat rotations, pasture and hay field, and there were even 2 sites that were taken directly out of woodland. But if you look at the blue column here, you can see that the lesion nematode counts per gram of apple roots are generally quite low, except for one exception here. If you look down below here, you can see that there are 4 sites with a non-recent history of apple production where corn rotations were grown extensively for a number of years. And these were outstandingly the sites in which the highest populations of lesion nematode occurred on the apple root systems. Now that to me, Michelle, is a really significant finding. And it might, for 2 reasons, because firstly, it might mean that the threshold for lesion nematode in apple replant situations is much lower than we originally thought, because as Tom Forge says, it might be that at lower levels, they can still operate synergistically with the plant pathogenic fungi to cause substantial damage to the roots. Or it might mean that nematodes are not really part of the replant complex and that the dominant players are the pathogenic fungi and umasites. So, I mean, it's really interesting, and we've got more research to do. Now let's talk about the soil-borne fungal pathogens. We were lucky also to have Dr. Ali Shawkat, who is a soil pathologist at AAFC Kenful, to help us with this investigation. Soil-borne fungal pathogens such as cylindrocarpin and rhizoctonia and soil-borne Oomocytes such as Pythium and Phytophthora are considered to be the main culprits involved in apple replant disease. Dr. Shawkat found that ARD pathogens ranged between 25 and 96% presence in root segments from the root samples that we took in the field. At sites with a recent history of apple production, cylindrocarpon fungal species appear to be more frequently associated with root segments when compared with Rhizoctonia and the oomocytes Pythium and Phytophthora. The conventional wisdom is that 1,3-dichloropropene, which was one of the active ingredients of telone, does a better job on the nematodes, and chloropicrin, the other active ingredient of telone, and the main ingredient of PicPlus, does a better job on pathogenic fungi and oomocytes. So what are the take-home messages? Firstly, with PicPlus, anecdotal evidence that it may be semi-selective. It may do a better job on eradicating or suppressing soil pathogenic fungi, but less so with plant parasitic nematodes. The efficacy may be more dependent on soil conditions when compared with telone. It doesn't seem to have the same penetrating power as it moves through the soil matrix after injection with the applicator. Optimal soil conditions are very important at the time of fumigation. The soil should be properly worked up and root raked as much as possible, free of sods and clods, at a temperature between 12 and 15 degrees Celsius, at or just below field water capacity, and preferably topped or at least well rolled after fumigation. The current recommendation is to continue the use of PicPlus in replant situation, paying careful attention to soil conditions. And remember, ARD is not the only reason for poor performance of newly planted orchards. There are always the 4 cornerstones of orchard establishment to consider, and they are site and soil preparation, address the replant disease, nursery tree quality, and care of young trees. I hope this presentation has been of help to you and that you will have greater success in establishing orchards in the future. Thank you.